Hello, in this video, we're going to discuss how to generate this semantic segmentation map, as well as the point clouds that can be generated using the depth map with the semantic segmentation. Okay, how to generate the point clouds. And finally, we're going to discuss how we actually generate the 2D cost map, which we show you at the bottom here. Okay, in this cost map, what we see here is the white area is represents the road. The black areas are represented by the obstacles. So the robot, when we do the dynamic path planning, we are okay to travel on the white area, but not on the black areas. All right. Okay, let's get started. All right, the first thing that we do is that we're going to download PIDNet. Okay, it's located here on the web in the GitHub. And once you download this, what you do is that you actually use this to generate the Onyx file. Okay, their model is located down here in the folder, and you convert that into a Onyx file. Once you have that Onyx file, then you're going to use the system-wide TensorRT, the command to generate the engine file. Okay, once you have that engine file, then you can go into this. The Python node, the ROS node code, and you utilize what you generated engine file. Okay, use that engine file to do the processing of the images. All right, so that's how you generate these semantic segmentation images. Okay, once you have that, then the next thing that we do is that we utilize that the segmentation image with the depth image that we publish from the Unity to generate point clouds. Okay, it's quite simple. So we have the segmentation image, right? And so it's a colored patch on the original image. Then we have a depth value for each pixel. Okay, since we know the color of the pixel, we know that what area it belongs to, such as road or tree, things like that. Okay, using the depth value, we can convert that the pixel color into a 3D coordinate value, and that's how we generate the point clouds. All right, so the point clouds that you saw in the RVs was basically how we generate the point clouds using this ROS node code here. Then finally, what we do is that based on the depth image as well as the segmentation image, what we can further do is that we can convert that into a 2D cost map, and we can use that 2D cost map to do a dynamic path planning of the vehicle. So the idea here is that once you have the segmentation of the original picture, then we have the color values of each pixel. So the purple color belongs to the road, green color belongs to the tree, and things like that. And for each pixel, we have a depth value. So what we can do is that for the travel is allowed road, we put on the floor, we paint that as a we project that onto the floor, onto the 2D plane as a white color, and everything else as a black color. So the white color represents the road, and black color represents the obstacles, and that's what you saw down here. Okay, so as you can see, let me make it a little larger. All right, so if you make it larger, so down here you see a depth map in the gray scale. All right, and on top, the color, the purple represents the road, and then these humans are or trees are, they all represents the obstacles. Okay, based on the depth value as well as the semantic segmentation, we can project that depth down onto the floor as a 2D value, 2D image, right? And all these road is represented as white, but as you can see, as soon as the human shows up, that represents as a black area. Okay, and then tree also shows as a black area, and then there is a human standing on over there, and that's what you see over here as the obstacles. And later on, we're going to use this 2D cost map to have our vehicle navigate. And as you have seen before, let me turn off the map and turn on the point clouds. We can also generate the point clouds based on the semantic segmentation as well as the depth image.